Hello, Algebra 2. Here we are with day 1 of section 5.2, long division. So our first type of division problem we have is a polynomial divided by a monomial, just one piece on the bottom. And our main strategy for these is to split them up and reduce separately. Okay, so we're going to have this over this, plus this over this, minus this over this, and reduce it all separately. So I have 6x to the fourth, y to the third, all over 3xy, plus 12x to the third y squared over 3xy, minus 18x squared y over 3xy. Okay, and now we're going to reduce each one of those individually. So we got the 6 over the 3 is going to equal to 2. X to the fourth over x is x to the third. Y to the third over y is y squared. Well, 4, x to the third over x is x squared. Y minus 6x, and y over y would cancel out. No y's in our answer. Okay, so we're going to separate them out into individual pieces and then use our properties from 5.1 to reduce each piece individually. Okay, you might see we'll probably written like this, times parentheses to the negative 1. Okay, remember that negative 1 is going to flip this all down to the bottom, and look what happens. It's just another way of writing it as a division problem. Okay, they just moved it up here and wrote it as a multiplication problem to the negative 1. Means we're going to flip it to the bottom, and now it's a division problem. So go ahead and try this one on your own. 18x squared y plus 27x to the third y squared times z all over 3xy. Split them up into individual pieces, reduce separately. Go ahead and hit pause and work on that one. Alright, welcome back. Let's see how you did. 18x squared y over 3xy plus 27x to the third y squared z over 3xy. Alright, so we should be getting 6x, and then your y's would cancel. Over here we have 27 over 3 is going to be a 9x squared y, and there's nothing to cancel out the z, so it stays there. Alright, take a look. Hopefully you got that answer with us there. On to the next. What happens when you're dividing by multiple pieces? Okay, we got x squared plus 3x minus 40, all divided by x minus 5. Another way you might see that is like this. Okay, how can I do that? Okay, what we have today is polynomial long division. We're pretty much going to be focusing on binomials, but we could also extend this out to more. Okay, so our main idea here, the biggest thing is you're going to talk about comparing fronts. Alright, so if I'm going to do x squared plus 3x minus 40 divided by x minus 5, we're going to be comparing fronts. Front of the front term divided by the front term. We got x squared over x. I'm not going to worry about what the rest of the stuff is. I'm just comparing fronts. X squared over x would reduce to x. So that's the first part of my answer, x. The front of this one divided by the front of this one equal to x. Now I'm going to multiply this back to both parts here. X squared minus 5x. And we're going to put parentheses around that and subtract down. X squared minus x squared cancels out. That's what we want. 3x minus a negative turns into a plus. So we're actually going to have 8x here. And now I bring down the next piece, minus 40. Okay, so that's one cycle, and now we just keep repeating that process over and over. Compare the fronts. 8x to x equals 8, a positive 8, so we're going to put a plus 8, multiply it back, 8 times x, 8 times negative 5, subtract down, 8x minus 8x cancels out, negative 40 minus negative 40 also cancels out, perfect answer, no remainder. Okay, you could also check this by doing x plus 8 times x minus 5. And that should FOIL out back to where we started, x squared plus 3x minus 40. Pretty nifty. Okay, we'll do one more together, and then I'll turn you loose to try that last one there on your own. Alright, so x squared minus 13x plus 12 divided by x minus 1. So I got x minus 1 out here, going into x squared minus 13x plus 12. You might be able to think about it in terms of factoring and come up with it really quick, but we're doing these easy ones first, hopefully easy ones, first so you get the hang of it, you get the pattern, get the routine, and then you can apply that routine to more challenging problems. Okay, so let's compare our fronts. X squared over x is going to be x. And then I have to multiply it back. X times x is x squared. X times a negative 1, negative 1x. Subtract down. X squared minus x squared cancels out. Negative 13 minus a negative, so plus 1 is going to be a negative 12x. And then I bring down this positive 12. Compare our fronts. Negative 12x over x is going to equal negative 12. So negative, so I'm going to put a minus 12 up here. Now I multiply it back. Negative 12x. Negative 12 times negative 1 is a plus 12. You can see that they're going to match up already. Minus, minus, cancel. No remainder, x minus 12. Okay, why don't you pause and see if you can do that one on your own. Alright, let's see how you did. X minus 3 going into x squared plus 7x minus 30. So we should have an x, multiply it back, x squared minus 3x, subtracting down, cancel, 7 minus negative 3 plus 3 is going to be a 10. And we're going to bring down the minus 30. Comparing our fronts, 10x divided by x should be a positive or a plus 10. 10 times x, 10 times negative 3. Subtract down, everything cancels out, no remainder. Perfect. Okay, so those are the quote-unquote easier problems. Okay, let's see if we can apply that pattern to something a little bit more difficult. For example, what if there's leftovers, there's something left at the end, remainders? How do we deal with that? So we're taking x plus 2 into x squared minus 8x minus 26. Okay, comparing our fronts, x squared over x equals x. Multiply it back and subtract down. X squared minus x squared cancels. Negative 8 minus 2, negative 10x. Bring down our minus 26. We're back to the beginning of our process again, comparing fronts. Negative 10x over x equals negative 10. So we put a minus 10 up there. Negative 10x minus 20. Subtract down. Negative 10 minus negative 10 cancels out. Negative 26 minus 20, so plus 20 is just a negative 6. Okay, so we got a leftover, we got a remainder. What do we do? What do we do with that? So that was a minus, so we can put a negative 6 over x plus 2, or you could have had a minus 6 over x plus 2. Just put your remainder as a fraction. Whatever you got left over, divided by what we're dividing by. You leave it off to the side. That's it. Why don't you try it with this one? This is going to be a little bit longer because it's x to the third. So you're just going to have to keep going through that for 3 steps instead of 2. Let's see how you do. Alright. So we had x plus 2, x to the third, 11x squared, 10x plus 6. Okay. Comparing our fronts. Over x, we should be getting x squared. Multiply it back. X to the third plus 2x squared. Subtracting down. Cancel. 11 minus 2, 9x squared. Bring down your next one. Compare fronts. 9x squared over x is 9x, so it's a positive, so I'm going to put a plus 9x. Multiply it back. 9x squared plus 18x. Subtract down. Negative 10 minus 18 is going to be negative 28x. Bring down our 6. Compare fronts. Actually, minus 28. Multiply it back. Ooh, we got some big negative numbers here. And subtract down. Excuse me. Negative 28, yep. Negative 56, yep. Okay, so cancel. 6 minus a negative, so plus 56, 62. So we have a remainder of positive 62, so plus 62 over x plus 2. That went pretty fast. Hopefully I didn't make any mistakes there. I'm sure you'll let me know about it tomorrow if I did. Last type of problem, what if there's a number in the front? What if there's a number in the front of x? Same process. Okay, just more multiplying to do. So we have 27x squared over 3x to compare now. Okay, the 27 over 3 is going to be a 9. X squared over x is 9x. Multiply it back. 27x squared plus 45x. Subtract. Cancels. 27 minus 45, negative 18x. Bring that down. Compare negative 18x divided by 3x, negative 6. Multiply it back. Ooh, no remainder of this one. That's nice. Okay, on that one for your own there to try. The last one, remember that times parentheses to the negative 1 is essentially the same as dividing. So go ahead and divide 18x squared plus 6x plus 3 by 3x minus 1. Alright, welcome back. Let's see how you did. 3x minus 1 going into 18x squared plus 6x plus a 9. 18x squared divided by 3x should be 6x. Multiply it back. And subtract down. Cancel. 6x minus a negative, so actually plus 6x is going to be 12x plus 9. 12x divided by 3x is a positive 4, so plus 4. Multiply it back. 12x minus 4. Subtract down. 9 minus negative 4 is actually plus 4. It's going to be 13. So we have a positive remainder, so plus 13 over 3x minus 1. Alright, you are all set for your homework. Okay, we're using the long division process there for homework for day 1. Okay, remember with the initial problems, if if you're just dividing by one monomial, one little cluster group here, then you're going to separate those into the individual pieces and reduce them individually. Okay, look at the difference there. We had 3xy was our denominator there as compared to like x minus 1. Okay, there's two pieces there. If it's just one big cluster, then you're going to use your first little technique of separating them out. Otherwise, do what we are doing there at the end. Best of luck to you guys. We'll see you next time.